Okay, I hope everyone can see my screen over here. So today, I'll be just we can learn Git. So just a quick recap, whatever we have learned till the last 2 days is a cloud computing part. So just we have covered the basics of cloud computing, what are the cloud computing, and we have chosen one of the cloud providers, just like called AWS. It's from Amazon as well. So that cloud provider, we just gone through a quick console. What is console? How to log in through console, and if we logged into the console, how the components look like, how we can spin up new components from this console inside. When the new spin up thing is ready, how to check that one from the console itself. Okay, so those kind of stuffs we have covered yesterday. And there are lots of things actually. We cannot cover the cloud things in within 2 days, but as this is a basic and very high level part, so just to give you a push or a quick heads up what the things and how the things are looking. And if you are, if you are quite eager, then I think I have provided or shared couple of information to have a free tier services from AWS. Okay, so today we can learn about Git. It is very much important one because if we are a developer, especially developer, not for the support members, so we are typing the code in Python or any other SQL module, anything. So the code needs to be stored in some places. Okay, nowadays it's remotes as well. We need to put it remote, and each of the version deployment, suppose today we are deploying something into production, some code version from the dev to production. Okay, maybe after 2 months I'm deploying another code version, some modification was there from the previous one. So this type of versioning part, version control part, can be controlled by Git as well. If and Git have the capability to certain features that I can check the historical commit, or where, for what reason, what kind of changes I have done in the history. I can track it from Git. Okay, I'll be just going ahead with more details in Git. This is a single session for Git. I actually there are two sessions earlier, but I merged those session in a single one. But it is quite understandable from the screenshots and for the documents and for the whatever I have mentioned in the slides as well. Okay, so I'll be going to start. Let me check if any others. Okay, some of them has joined over here. Fine. So let me start off the thing over here. Yesterday the particular recording was not good, so recording was broken for yesterday. Hopefully today it's fine. So what is Git? Git is a version control system. Whatever development we are doing over here, or we are saving this thing in a particular code based repository, that repository is able to track the version. Okay, Git is a free and open source, no licensing cost or just like this for Git, and it distributed in nature. Distributed means, multiple person can be work in Git, and it can be distributed as well. It can be hosted in cloud. Nowadays, everything is in remote. We can store our project in remote. Okay, I'll be coming to what is branches and all. Different persons are working in the same project. So maybe in a particular application, there are hundred of developers are there. Okay, it's a big application. There is only single repository. Then how they should be working? It should be distributed in nature. Otherwise, all of them should not be working in a single Git repository or single Git project. Okay. Then from the next topic, let me just is the size features. Can anybody check whether the session is being recorded? Not sure actually.
Yes,
Yeah.
it's recording.
It's
Okay.
recording.
Okay, fine. Yesterday, actually, when I tried to pull the recording to the portal, I found that no recording was done. So not sure it's from my fault or whether I have forgot to record or maybe it's whenever I have started the recording, maybe it can be some issue with that particular file or anything. Okay, fine. So now the question is, what are the different features for Git? So the same thing, just like we can track the changes across multiple files. So, it's a repository based thing. So we have a folder structure where we are storing our code bases into separate files. Okay. Suppose we are creating hundred of SQL files inside a folder. So then I can told that folder is a code based repository, and inside the file we can put a.sql file. Inside the SQL file we can put all the DDL. Okay. And I have another SQL file called b.sql extension. Inside that file, I can put all the DMLs for insert command and all. So in the third one, I can put all the store procedures or any select statement is there. Okay, so we have lots of file. So whatever files are there, we are storing it over there. So maybe in a week we need to push it or commit the change. So whatever we are changing, we have to commit it. Commit is just like committing the thing that it's a save point. Maybe Friday is the day for saving our work. Okay, entire weekend we can modify the thing, and Friday we can modify and save our works into the folder. So that is we are changing something inside the folder, but Git has the capability, it can track the changes. In last Friday, what changes I have done in the same file, and the next Friday, what are the other changes? Okay, so that kind of track changes can be done. Multiple files, time travel into older version. Okay, if something I have done, some mistakes I have done in my current version deployment, I can quickly jump to the previous one. So time travel is there for Git. Roll back to previous version, I can roll back, collaborate and share changes. As I told that multiple teams, a team should be working for the file changes. So I can collaborate between them and I can share the changes, combine the changes as well. Maybe multiple teams are working or multiple persons are working in a single file. You can combine all of our changes into a single file. We can compare multiple versions. Okay. I mean, maybe last week I have pushed some changes, and this week I'm pushing some changes. In the very next week, I can compare what are the changes between both of the file. Okay, so compare versions of a project that can be easily doable. So those are all the features. Why we use Git? That's a theoretical steps over here. Just to let you know what is the feature of the Git. Okay, what is the next topic? Okay, now I think you have already heard that GitHub keyword. Okay, so Git and GitHub, it's not the same actually. So there are lots of difference, but the first difference I just want to mention, Git is a software. Okay, so Git is the main thing, and on top of the Git, there are lots of service providers available in the market. So one of them is GitHub. Okay, so this is a main concept. Even I have also wrong concept earlier. So Git and GitHub are the same thing. Now Git is the main software. Okay, and GitHub, it's a tool. There are lots of services on top of on based on Git. We have GitLab as well. So that is the tool. If we just install Git, we have the command line interface. So we can do the changes or anything by only command line. But GitHub is it's a service on top of Git. So it is having its own graphical user interfaces and all. Okay. So lots of differences are there. Actually, those are not very important, but you can just quickly go through. Okay. Another main important, I'm just putting the thing. In market, Git competes with those kind of softwares, just like CVS, Azure DevOps Server, Subversion. Those are all the competitive uh, components of Git, but Git is the most popular one I mean, most of the project you can see there using Git only. Okay, and GitHub competes with those kind of things. GitLab, Git bucket. Here, not only GitHub is the dominating one, but we can add more about Git. We can also check more, how many of the projects they are using also GitLab, Git bucket, and AWS code commit. This is the cloud one that is using GitHub kind of stuffs. Okay, so just a basic concept. What is Git and what is GitHub? Don't just mix these things up. But in our project, if we are live with a project and everything, they are using the services. Okay, GitHub. So GitHub or GitLab, anything in the remote. So whatever we are changing in our, I mean, project purpose or anything, that thing should be present in the GitHub. In the remote version, remote repository. Suppose it's a portal. In the portal, the particular changes is being tracked over there. So GitHub is doing that stuff. Okay. So I'm going to the next slide. Hopefully, the basic understanding what are the difference between Git and GitHub is clear. I'll be starting with Git in the next sessions and all. So if you just, I mean, what is Git? First of all, Git is a software only, nothing more than that. So Git, you can install the software over here in this official website of Git. Let me just paste the same thing to you. Okay, let me show as well. If you just go to Git, this is the, I mean Git portal over there, gitscm.com over there. This is the particular, I mean, resource. I mean, the particular component for Windows, and you can install it for your Windows. Okay, let me paste this thing in the chat window as well. Okay, if you install it, how it should look like in the Windows button, you can see where is my window. Sorry. So after installation of this, you can see it in this way, Git bash. Okay, this kind of icon will be created. So this is a command line. I mean, if you just double click on that, so it should be working as a command line prompt. Okay, so on top of that, you can work. You can install it in your local, and you can create a repository. How to create the repository and all, I can share you with the thing. But this is the way you can, I mean, install the thing and work on top of Git bash only. Putting the command. The command should be most likely looking like the shell script. If you are quite aware what is shell script, if you have already worked in Linux or Unix, then that should be very much useful. I mean, shell script means, I mean, suppose you are going to Linux directory by opening putty or any kind of stuff. That's like if you want to create a new directory or new folder structure, so the command should be mkdir, make directory. Okay, so you can create a new directory in a particular location, and just like you can go to another directory, just like change directory, cd, present directory, pwd, or this kind of stuff. Lots of things you can just go ahead, remove the files, rm. So copy the file, cp. So those kind of command you need to first of all have a bit experience how shell script is working. Then this is the same kind of stuff so you can use in git bash as well, except we can learn some more git command. Okay, shell script command should be same. We can learn some more git command in this chapter. What are the git commands and all. Okay, so moving to the next topic, just what are the graphical user interface for the git as well. Those are the softwares you can use. Just like source trees it's very much popular one. Tower, there's tortoise, github desktop, it's also very much popular, which we can connect with git, and instead of writing the command in git bash, in the graphical interface, there are the buttons are present, the same kind of. I'm just going to add, going to go add some commit statement. Okay, the same kind of button is there, so I can click on that button and it should be committing our branches to the main branches. So the Git desktop is there, Git Kraken is there as well. So everything is there, but inside the course, we can just go ahead with Git Bash components. What are the different uh, commands are available over there. The same kind of buttons are available also there, but I'll be going through Git Bash commands and all. You can have the idea in your project. If you are using any GUI, then you can, that idea should be also helpful over here as well, because you just need to know what button should be working for which purpose. Okay, so I'll be just covering the command purpose, then but you can have some reasonable thing what we are doing over there, and the same thing you can do for Git GUI. Okay, now it's time for start with what is Git and all. How the Git should be working. For Git, the main thing is Git need to maintain a repository. Okay, so inside the local, if we install the Git Bash, how should I create the repository in the how should I create it in our local? How to create it? So just go to this. Okay, if we have Git Bash, just double click on that Git Bash. Just move to the particular directory. Just you want to create that repository. So opening the Git Bash in command line window, I can type cd and I can go to a particular directory, just like I can type this one. I do not have the Git Bash install over here. That's why I'm not able to show you. But let me help you how to do that thing. So suppose I have opened the command line interface. Suppose it's a command line interface. Okay, it's not command line, it's a notepad plus plus. But you have opened Git Bash. So just go to the particular folder structure where you make it, where you want to make it as a particular repository, which should be under Git's control. Okay, so just go to this drive. You are now in this drive. Now what you have to do, so you just need to choose that particular thing, and this is the particular command git init. Okay, so in that, if we are in Git Bash, we just have to type git init. That folder structure would be a repository which should be under Git's control. Okay, so inside that repository, whatever files you were storing, that particular works we have done in development side, so that thing we can store over there inside that folder structure. Okay, and that can be under Git's control. Whatever changes we are doing, that should be controlled by Git. Whatever we are committing, any new changes inside that folder, that can be easily trackable by Git. Okay, so before doing the git init command, we can quickly type git status. If that folder is under Git, it will show everything, just like anything to be committed, anything is uncommitted, what is the status of this folder and all. That can be done, but that can be visible by using git status command. If we can see that folder structure is not inside the Git, then we can quickly create this repository by typing git init. Okay. So git in is to create the repository, git status is to check how to, what are the status of this current folder structure. What are the status of this repository? Any file is uncommitted or what is the status? Okay, so this is a graphical user interface. I just took a snap. Here we have all the buttons available. Whatever we will be learning over here, it's very simple. I'll be coming to this picture once more time in later session. Let me cover up the other thing. So in my particular topic, we are finding this keyword commit. Okay, so I mean, I'm changing the part. I'm changing inside a particular repository. I'm creating a new file. I'm changing something over there, but I'm not committing it. If I do not commit this thing, then the particular thing will not be saved. I mean, inside the Git. Okay, so it should not be under Git's control till I'm committing it. Okay, so the committing that's I mentioned in each of the project, maybe there are some rules. I can work entire week, and at Friday, maybe the last day, I can commit what changes I want to merge in our repository. Okay, I think I'm understandable. Suppose I put lots of developers code, but I do not want that thing to be merged because I'm not sure whether the requirement is finalized yet. And maybe there are some important things at the previous file. If I merge the thing, I mean, lots of works have to do again in the next repository, but that cannot be the scenario as well. Maybe whatever I'm doing based on my assumption, if my view IT checks this thing, maybe he can be angry. So I should not commit this thing from my side either. I mean, if we do not get any confirmation from view IT or my project manager or anyone, so that's why committing should be done in periodical interval and all. So, I mean, what are the steps in commit? So I'm working this directory. I mean, I'm changing some file. I can add, I mean, this thing in staging area by this command git add. Okay. And okay, anyone is saying something, please tell me. Or it's a noise. Okay, I hope it's a noise. But if there is anything, any doubt points or anything, please feel free to ask. Okay. Okay. Uh, okay. So the working directory means the repository where I'm working it. So I can add it, git add command. It should be in staging area. It is not committed yet. It should be in staging area. I can put whatever changes I have making for today or every day. I can just put git add command. Okay. On the last Friday, I can push the changes in the repository. Repository original file name is there. Suppose a.sql, b.sql. I am modifying the entire week in a.sql, b.sql. And the last Friday, whatever tables are confirmed, I can just push those DDL changes. Okay. Inside the main, the repository, the a.sql can be updated if we just run this command git commit. Okay, so that is called commit. The same thing in the graphical interface, I want to mention this thing. Those are called commit point. Okay, this is a branch. The branch is tracking what are the changes. We can see the description is present over there. So I have moved something. I am fixing something. Okay, I'm removing something. So each kind of stuffs we are committing the thing. Sorry, we are committing the thing inside the branches. This is a commit point, this is a commit point, this is a commit point. Okay, if I want to go to the previous point, git will help me to check what is the code version into the previous point. So this is called time travel. Okay, and those are called branches as well. I'll be coming branches again quickly. So you can see I'm just a particular developer is working on this green branch. A particular developer just check that he needs to add some functionality from this point. He do not need that save point because maybe a file, it's a big file or big development application. Someone is working some particular code module. Maybe someone is working a particular DDL, not from other DDL. Okay, so they have chosen this one. From this commit point, they have created a branches. They are changing their stuffs, and over there they're merging it with green again. So these are the branching concept. I'll be coming this thing again in after a few slides, but this is called branches, and this is the commit points where we are changing the thing. And from the committing stuffs, we can retrieve the thing again. So that's why commit is important. And if we commit it, the thing is under version control. I mean, this is a separate version, this is a separate version, this is separate version. So this version can be controlled by Git, and we can take this thing anytime. We can compare between two versions anytime. Okay, Git can store all this information in its history. Okay. Moving to the PPT again. So hopefully Git commit is understandable. Okay, creation of branches. I just mentioned that why we need to create the branches. If multiple developers are working in a single application, then we need to create the branches. Even if, if only single developer is also working, we can create branches because there is a main branch that is called master branch, where, that particular branch is the main thing. Our DUIT or anyone, when the that particular development thing is going to production, pointing to a main branch, then the code base, our manager or our team lead can see only the main branch. They will not see our individual works branch. Okay, but while working, I'll not be modifying the main branch. Rather, I'll be creating a feature branch from our side, just like the same thing I showed to you, that branches we can work. Okay, we can work inside the file, and we can commit the thing. I can push the change in the main branch. When everything is fine, I can push the change into the main branch. Okay, that is the concept of branch. By doing the branching thing, multiple developers can work in multiple a single file or multiple files in a single folder or single repository, rather we can say. So that is the concept of creating branches. So when our work is done, we can merge the thing with the main branch. So this is our branch and this is the main branch. So when it's completed, we have to merge it with the main branch. Okay. Okay. So this is the codes and all. And you can see a concept as well. This is a master branch. Maybe those commits has been done from other branches, other feature branches and all. Or maybe a developer or a particular program manager, they are directly working in the master branch. Okay, but I'm a new developer. I joined just a few days ago, so I have a little bit risky to do this kind of commits in master branch. So from this point, this commit point, I have created another branch. This is a new feature branch. So how to do that? Just git switch branch master, git space switch master, a new branch should be created. Okay, so over there I can change or I can do anything. When everything is completed, when I've committed my changes, I can push these changes to main branch. I can merge it to the master. So the command should be git merge and the feature branch. Okay, this feature branch name I need to put, then it should be merged back to the master branch again. Okay, now there is called merge conflicts. Suppose someone has already in this commit point that the team lead are changing from the master branch itself. So they have also taken a.sql and I have also taken a.sql. So same file has been modified and we can merging it over here in this commit point. Okay. So that time the merging conflict should be there. Git will throw the error that there is merging conflicts. So to remove this kind of stuffs, we need to check what are the conflicts. Okay. So the changes, and we need to check what particular changes we need to populate, whether my team leads is the updated one or myself, or maybe there are two different thing. Both of them should be kept over there. So manually we can update this file and push it again to the main. I can copy, maybe both of them are required. So I can copy both of the codes over there and I can push the change. Then there will be no conflicts again. Or I can discard one of maybe my changes or maybe my template changes, any ones which is not required. I can remove this thing and I can push it to the main. Whatever is required, I need to do that thing. Okay, and commit it over there. Any doubt till now from anyone? What we are learning? Okay, hopefully no. Going to the next topic. Okay, what is Git stashing? So suppose we are changing something in my working directory. Working directory means maybe my feature branch and all, or maybe my main branch, anything. But someday I just received a new work. Okay, so whatever changes I have made in last 2 days, so that changes, I mean, the new work should not be dependent on that one. But this last 2 days changes are very much useful. I can I need the changes in later section. Maybe after 1 or 2 weeks, I'll be working to these changes again. Okay. Then what we can do, we can stash the change. Whatever we have done in last 2 days, that was uncommitted one. So that can be stashed. Okay. So maybe that is in staged area. Maybe that thing is not in staged area. But whatever changes we have done, that can be stashed. And the command is git stash. So it's a temporary location where we can push those particular 2 days work in somewhere else. When my current work is completed, then I can pop this thing again inside our developer branch, just like git stash pop. Then I can work on top of that 2 days work, what I have done earlier. Okay, this is also important concept. So maybe I'm working, I have completed lots of works in a particular topic, but suddenly anyone can told as of now it's not a critical one. We can cover these things up after a few days. Then we can do this kind of stashing operation. Okay, so it can be committed. Stash should be working only if it is not committed one. It should be ready to commit. Maybe I have already added into staging area. I do not added it staging area. Both of the cases it should be working, but the file should not be committed. Okay. Okay. Now I'll be entering into GitHub. So just I'm mentioning the definition once more time over here. What is Git and what is GitHub? So Git is a version control software that I already told that runs locally on the machine. No need to register for an account. Okay. And no need to register for an account. And okay, I put this thing twice over here. I need to delete. No need for internet as well. Git is not mandatory internet required because I should not be working in my remote as well. But if I working in a service in a particular or practical application, or if I working in a project which is live or just like this, then we need to use its services, maybe GitHub or GitLab. So it is a service that hosts in Git repository in the cloud and makes it easier to collaborate with other people. So in our project, when we are live with our application or when we are going ahead with our teammates to do the changes and all, we will be using GitHub. No need to use Git. Git, just the concept should be Git. I mean, Git should be installed somewhere in some other servers. Okay. On top of that, GitHub, the service we will be using. Okay, but we can check only the portal. When we'll be working and at a project, we can open the portal. No need to open the Git. We can check the portal. We should be only using the services. Even there, if it's a big company we are working on, we do not use the maybe the scenario should be even we do not create the repository from our side. Okay, we just need to raise the ticket. The particular DevOps team member, there are some team members or support team members are there controlling Git stuffs. They will be creating the repository for us. Suppose our new application should be there, we should be a developer, we should be the developers of this application. We can tell the particular team member, the support team will be supporting Git stuffs. We can tell the team member that please create this repository. We'll be storing this kind of stuffs. Please create a repository on behalf of us. So we do not have direct control because we are the data engineers. This courses is for the data engineers first. So that's why I'm telling this thing. Maybe they will be creating the repository over there, but we are responsible for creating branches over there. Okay, creating branches, creating folder structure inside GitHub, inside that portal. So how to do this thing? Let me show you. First of all, GitHub, there are URL based thing. So we have the URL to log into GitHub. Inside the URL, we can create those kind of folder structure. And inside this folder structure or directory, we can push our changes, push the SQL files, Python files, everything. Okay. So this is one steps we can change directly at the portal, but this should not be the good approach. Rather, what we can do, whatever folder structure are present in the remote area, we can clone the same kind of stuffs in our local hard drives. Maybe in D drive, I can create same kind of folder structure. Then the particular things is called cloning the thing. So then we just have to go to the structure and suppose I'm CD that folder structure, and then I can do these things from git bash as well. Git space clone space the URL. URL means that particular remote repository, remote GitHub repository. I can write it over there. If I just clone it, from which directory I'm cloning it, from git bash, the particular thing should be cloned over there. Okay, so it's a local repository. The same working, the remote repository is the main thing over there, and I'm creating a local repository. Now I am changing everything in my local, but this is my local repository. Git is also tracking this thing, my local Git. This is called Git. Now Git is playing over here. When I'm cloning it over here in my local Git will be tracking my changes. Okay, it will be showing that I have changes this file these days. Do you want to commit? Or just kind of things. This if I just press Git status inside my repository. Okay, so GitHub, we can, if this is a small change, no need to clone it or no need to change from clone. If it is small change, I can directly open the portal. I can open the file. I can update the file and I can commit the file over there, putting some description why I want to commit. So that way we can directly commit the thing from GitHub. But if there is a big change, big deployment should be there. Rather changing the thing, we can change the thing from our local repository only. If everything is fixed in local, we can push the change in the remote clone, the URL repository. Okay, that's the commands are present there. That is called git push. So suppose we are doing the big changes in our local repository. We have changes everything in our local. We are writing the code in PyCharm, and when the code is final by trial and error method, I can push the change in our local repository. In local, I can commit it, and while doing the commit, after committing the thing, I can push the thing to my remote branch. Okay. So pushing just like exports the commit to remote branches. So local is the updated one. I'm the developer. I have updated my local. So the same thing should be the same folder structure or same file, whatever is updated, that can be pushed to the remote one. Okay, hopefully that is understandable. Similar kind of stuff is called Git Fetch. So if maybe some other developers have pushed some changes into the remote branches, I also need that changes at my side before I can push anything. So then I can check just like this thing, Git Fetch remote. I'll be fetching everything my local, but it will not be committed. Okay, fetch will not the committed. So there is a difference between git fetch and git pull. Git pull, if we just type git pull, then it will commit everything what is not committed. What is there, what changes I am preparing, it will not check. Rather, it will check the differences between the remote and my local. If remote is having extra changes, then it will pull those changes and it will merge everything into my local. Okay, so git pull is a risky one. Rather, we can check for git fetch. Git fetch, we can just copy all the changes in my local, but it will not merge the thing. There is an option git merge. A command is git merge as well. If we just execute this thing, then those page can be merged. So pull is a single statement. We can do the same thing. Generally, we also do pull when we are 100% sure that that should be pulled. I have committed everything in my local. I just need to pull what are the recent changes from the other developers into my local. Then we can directly pull it. But fetch is the safest option. We can fetch it first. We can check what are the new files or what are the changes are there. Then we can merge it, git merge by the git merge command into our local system. Okay. So fetching imports, it will be importing the thing. Push is exporting the thing, exporting from our local to remote. And git pull is importing from remote to local. Okay. So git pull, I just covered it up. So over here as well, we can find this kind of conflicts as well. When I'm pulling it, then I have changes in some file and the same file has been modified from anyone from the any other team or any other developer, but it's in remote branch. My branches has already been updated. I'm pulling it. So this kind of conflicts is there. So you can remove the conflicts, manually change the thing, or rather the best approach should be if I'm going to change anything over there, I need to check whether there is previous change is remote. So before committing my stuffs, I can pull all the updated one. Okay. Then I can change my commit. I can commit my changes. So this is the best way or approach. So if I'm just going to commit any changes for a particular file, before doing that, I can pull all the existing changes there. So I started developing a code for 7 days. In 7 days, someone has changes that file and pushed it into Git remote repository. So that's why before changing my thing on the seventh day, when I'll be pushing my code, before doing that, I need to pull this code again. Okay. So I can check if there is any new thing. Then on top of that file, I can stage the change or I can drop the change in somewhere, some place. I can copy this thing and I can paste this thing over there. Then I can push the change into commit form. Okay, this is the ideal way we can approach it. Then no such conflict should be appear. Okay. Okay. Now there is another stuff for PyCharm. I'll be just showing you. Present IDs or present this kind of software, we can do multiple ways. So just like I told, I can create the remote repository if I have the PyCharm with my side. Yeah, PyCharm is there. So suppose there is a remote repository and I have cloned it at my side. Okay. By PyCharm, I can point to this project folder, new project, and I can open from my directory, which is the local folder structure. I can directly pointing to this thing and open the same thing over here. I can make the changes over here and I can save it to my local itself. So when my local is ready, I can push the changes to the remote. This is the conventional way till now what we are doing. But nowadays, this kind of IDE has the ability they can directly work in remote. Okay. So over there, we have the options to connect with the remote repository itself. Okay. So we have the options for, connect to the remote. Let me show you the screenshot itself because I am doing this thing from local. Let me just maximize it. So over there, the Git option is there and all this kind of push, pull, those kind of stuffs is mentioned over here directly. So I can control directly in a remote branch itself. In the remote, there is a master branch. So I have created a branch, a feature branch from this master branch. And this feature branch is being called over here in the PyCharm itself. So whatever modification I can modify it over here, I can commit the changes in my feature branch, which is being developed from my side itself. And if I'm quite sure that my feature branch is good, The testing is good. I can switch my branch to feature branch to master branch from PyCharm itself. I can push the change inside the master branch in the remote itself. Okay, this is the concept I just want to share. So no need to change the thing from our local and push it again to the remote. Rather, we can directly working in remote, creating another branches and working over there. So nowadays the software has those capability over there as well. Okay, I just try to mention the same thing. So I think we have already completed the basic stuffs, or not only the basics, as per the developer how to control the thing from the Git side and all. I think this is the last slide. Let me check if there is anything more. No, there is nothing. So till now, any doubt from anyone? What is pull? What is push? What are merge conflicts? Why we stash it? What what is the branching concept? Why we require branch? Any doubt from anyone? Okay. So hopefully no doubt. You're able to understand it? Fine. So we have covered today's session for Git. Git is single day session. So the next day, just I told, next weekend I'll not be there. Next weekdays, Monday or Tuesday, I'll be confirming again to Lohit or any of the admin team members. They will be telling you the finalized one. Due to some issue at not only issue in personal reason over there, I'll not be able to take the classes. There will be 2 or 3 more classes for the next week, and the session will be ended in next week itself. So the 2 or 3 classes should be top up uh, big data part. I'll be giving you some concept of big data because I am the developer in the big data side. So over there, I am developing the codes nowadays. I have some experience on the big data, so I'll just giving you some concept. What is big data? How the distributed data is working. So I'm working in PySpark actually. I do not have the. I work in my company, but I do not have this thing. Set up in my local system. So that's why I could not show you the thing